Well, hi, and thanks for joining me in my shop here today for the Battle of the Baby Champ radios. Those two radios you see on my bench, I just recently finished doing the restoration or repair work on them. The two of them are in pretty good shape now, and I think some interesting stuff can happen if we spend a little bit of time comparing the two of them. Not only the way they look and stuff like that, but also how they operate, obviously. So, how identical are these radios? Pretty close. Maybe not perfectly identical. Here's the cabinets that go with them. Okay, I mean, those rank as pretty identical, except one brown, one painted white. Now there is some information on the back of the radios too, but I've already looked at it. It's identical, except this one has an extra sticker that says you can pop out the 35L6 and pop in a 50L6. But wiring wise and that, I think they're both pretty identical. So let's take a close look at the two of them. We'll see if we can identify any significant differences. Something that might affect their operation. I can see something right away, jumping right out at me. The antennas are different in these two radios. How different? I don't know. Let's see. We've got a terminal strip. You know, orange and green, black and green. Green is the, looks like this is carrying the signal right over to the capacitor, and green is going to, yep, same thing over here. So a little bit of difference on the antenna. Could just be the size of the wire, I don't know. These radios come with a somewhat hidden trimmer right down there, and both of them have it. There's nothing different about them. Let me just hold my camera right above it here and just look at the two of them. What looks different in here? Busily just snapping my eyes back and forth. Position of the speaker transformer is different. Can't imagine that makes any kind of big deal difference. It's a K38739 and this is a K38739. It's the same transformer. Everything else looks identical. Capacitor. Let's flip them underneath now. Let's see, the front has a number here. Exactly the same number, of course. No surprise. Let's flip these up onto their sides. Compare what's underneath. I just put my finger through the speaker. Son of a gun. Okay, well, we know one difference. One speaker has a hole in it now and the other one doesn't. So just snapping my eyes back and forth again. Of course, I haven't replaced these three. These are original. You can see the replacements here in this radio. See, this resistor is a slightly different style. This is a longer one. It doesn't mean anything. And just looking for differences here. Just flipping my eyes back and forth quickly. So in this radio, I've left this resistor. I don't think I paid any attention to it, but I changed it in this one. It all looks extremely similar, doesn't it? And it should. It's got a number on it here. 812513. This is something, probably 52513. It's the same. It's the same deal. I thought maybe that, no, that's for the oscillator. So be something related to the antenna that would be different. So I left in a paper capacitor on the antenna on this radio, and I think I did the same on this one. Yep, exactly the same. Paper capacitor still up there. Interesting question would be, did the same individual build both of these radios, or same individuals build both these radios? And here's something really interesting. Look at this. Look at this green thing here I noticed before. The power cord comes in with knots on either side and this green tube in the middle. And this one's got exactly the same thing. And I thought these were replaced plugs. Maybe not. Maybe these are the originals. Or the only way this is like this is the same person change the cord on both these radios. That's possible too. As far as I know, the person I bought these two radios from bought them together from someone else. I don't really know for sure. And that person may have done a little bit of work. I mean, there was some similar work done in each one. He'd augmented with a capacitor, and the same thing had been done in here, which I I went further with this than this radio in terms of the power supply filter. Yeah, and you know, nothing's leaping out as dramatically different. Nothing at all. Okay, next step I guess would be we're going to play these radios. Let's see what happens here. So I want to compare these in a fair way, but far be it from me to do this in a truly scientific sort of way. Can we call it pseudo-scientific comparison here? One of the problems is having the same antenna arrangement for the two radios, so they're experiencing the same field that they're tuning through. I think I have a way of doing that. But for now, we just leave them totally alone, all by their lonesome here. Their own antenna and nothing more. Now what we want to do is plug both these in. Now there's a bit of an issue here in that these are 5-tube radios, no transformer, no polarized plug, and no rhyme or reason for how the wires at the end of this are connected in the radio. No, there's a rhyme and a reason to it, but there are two rhymes, this way and that way. So if I plug both these into the same outlet, and I have the plugs in a certain way, in any way, I think in almost any way, I can find voltages between the chassis and stuff like that. So that's what I want to check for first off, before we get too far into this. So I'm going to make sure both radios are turned off to begin with. Both are off. Okay, I just took a guess. I didn't even take a guess. I just plugged them in without didn't even think about it. Now, I gotta find my voltmeter. What have I done with it? Can anybody tell me where I put my voltmeter, please? So what we're going to look for is the voltages between the chassis and between the B- point, which I can't get out with them down like this. But let's just check with the chassis first. We'll just check it. Now, as I explained before, this goes to a transformer. It doesn't just go to an outlet. It goes through a transformer, so this is isolated. So these guys are running off of a 120 volt transformer. Okay, with the switches off, power applied, what do we get? Couple volts. Let's reverse this. One of them. If I'm going to be comparing these two radios in my shop, I want to know if I'm going to get a shock before I get it. 124 volts. So now, even though this is not plugged into a regular, wall outlet, it's going through a transformer. That's a real 124 volts, and if I stuck my fingers where my probes are right now, I would start singing some song and you wouldn't recognize it, I'm sure. So let's flip those right back, but that's not the end of the story here. Let's flip those back. Don't think that's the end of the story. Oops. Volts. So once again, we'll just have a little voltage here now. Right down to 0, in fact. That's very reassuring. Now, I'm going to turn one on, but not the other, and we'll see what happens here. And we will turn on this one. Still 0. Good. And we will turn on the other one. Anybody notice anything there? When I turned this radio on, this light came on bright. But with this radio, there was no light. That's a huge difference. How could that be? Okay, let's just give them a minute here. Double check, just because. And I'm going to double check to a power ground here, just about any piece of equipment. Like that. So you see the 50 volt reading. Now that's roughly half of 120. And so what that's telling me is that's some kind of capacitive coupling between the chassis I'm reading, and I can't really see what I'm doing there. Okay, so I was just holding the prod here and holding this on any grounded piece of equipment. Here's a spot right here to get that reading. If I were to touch the chassis and then grab a piece of equipment, I would have 50 volts across me, but the amount of current that could flow might be very low. In other words, or another way of looking at it, the 50 volts might virtually disappear. Maybe not, though. So I can't be absolutely sure. Now, what's going on with the dim bulb thing? This is a bit of a surprise. So I'm going to turn off this radio. We'll see if that dim bulb stays on. Whoops, not with this control. Okay, so the bulb went out. So maybe it's just, two radios draw enough power to make that bulb show up. Let's watch the voltage here, and that'll help too. So we have this is actually, we can do this. Let's do this more appropriately. One radio on. Okay, I'm going to cut the light bulb out of the circuit. This is now running with 123 volts. What was my smart idea? To read the wattage. That was my smart idea. So I can read the wattage here. 28 watts, and I believe it's rated at 30 watts. So 28 watts. And we'll turn on the other radio and see if this doesn't come up to double 28, which would be 56. 63, 68, 54, 52. And hopefully that'll settle in right around 60. I don't know why I said hopefully. Okay, so I'm going to turn off this radio. So 25.5 watts, 25 watts over here, almost 30 watts over here. What would the difference be? Oh heavens, could be almost anything. 4 watts. Could be the light bulb. Is the light bulb a significant factor in this measurement? I can't imagine. This has to be a quarter watt here or something. That says 24. 24. I think this is a quarter watt light. 24. Yeah. 25. Huh. Oh, it can't be the light. Okay, what's next on the list here? So we have one drawing a little more power than the other. Maybe it's the tubes in some way. I don't know. Let's switch them back on. Switch it back on. And we'll start listening to these two guys. Now, they're just arranged at right angles on my bench here. Just straight across. That's kind of arbitrary for the antenna direction. Let's see what we get. And we're running these on full line voltage now, which is wrong button. 123 volts. Okay, guy on the left. Here, let's come down to earth here and watch this. Guy on the left. What's happened to the guy on the left? Oh my gosh, what has happened to this control? Ay, ay, ay. This feels like it's busted inside. This is the volume control. It feels all crunchy. It's, and where's the sound? Oh my gosh, what am I doing here? Oh, okay, come with this one. Thank God one of these works. And that's the comparison right there. The winner! Baby Champ right. Baby Champ left. What happened to you? What happened to it? Okay. There's zero sound coming out of that. No, that's humming a little bit. That's humming a little bit. I think the volume control has failed. I can't believe it. You can hear it. It feels like crunchy in there. Oh, crunchy good. Not a sound out of the radio. Oh, could that happen? Well, I don't know for sure that that is really what has happened. I have to troubleshoot this radio now. This is not the idea. You know what's happened? This guy is so intimidated by this one, he won't even try. He won't even try. But I know. He's running even a little bit better. You should not be... Let's turn this off. Oh, I hear the crunchy stuff there. Oh, man. What? Why do you do this? Right at the exciting moment. The last thing I did with this radio is I replaced 3 capacitors and I did not test it afterwards. My guess is that's really what's happened here, is I boobed it up somehow. Or maybe a cold solder joint. Because this capacitor is supposed to convey the audio. Maybe I made an error with this. Hey, I have another radio. Hey! Oh. Let's just pull the plug out of here. Leave them off. Here we see this coming over onto the terminal. That's the correct terminal. It's a smaller wattage resistor here than the wattage resistor there. Let's compare them all. Okay, so this guy goes here, comes up to the ground. Yep, this guy comes from the ground over to here. That's the terminal with the same thing again, smaller wattage resistor here and a larger wattage one over in this radio. So I guess maybe as the time went by they figured out they could afford to put smaller and smaller wattage resistors in. Well, I don't see any differences here. What about this guy? What about this one? Now the radio worked. So he's there. It's exactly the same as this one. Okay, let's turn this radio on. I can't believe I'm doing this. Okay, it's plugged in. Switch it on. Let's get the signal tracer going here. Signal tracer here. It has its own hum, by the way. I'm going to attach this to the B minus point, or one of the B minus points in this radio. Lots to choose from. Great big honking clip. So I really want to pick one that this clip won't do anything bad. Yeah. I think this is probably the best one right here. Did I just whisper that? I did, didn't I? Okay, now the objective here is to find out what's happened to the audio. So we'll set this on audio. This tape, by the way, is just holding this cap on, or the cap will slide off. So inside this big thing is a vacuum tube, and the grid is produced out here. Whoop. So that's right onto the grid of the tube. Very, very, very high impedance that way. Super high. So there's audio sent over to this control, and we should be able to hear it. What is reaching it? I'm just checking. Okay, so it's coming right from here. So I have my hand on the volume control over here. We should hear this when I turn it up. So that's what's heading to the volume control. Can you believe it? The volume control gave up the ghost. Other end of the same wire. And then this is on the output. Oh, wait a minute, it's still there. This seems to be okay. The sound you're hearing is coming out of my signal tracer. It's not coming out down here. Oh my gosh, it is coming out down here. But it's not coming out of there. Okay, so the grid of the output tube, can he remember? Can't remember. I cannot remember. Grid is down here. I think it's this guy right here. Don't hear a thing. It won't be up on this. Maybe not that one. Maybe this guy. This guy's doing it. This is the guy. So I should hear it here. Whoops. Whoops. Boy, I'm lucky I didn't blow something up at that point. There you are. That's the first time you've seen the dim bulbs actually do their job in my shop. That's the first time I've ever introduced a short and had the bulb come on. So there you go. Saved me. It really did. If those bulbs weren't there... Wait a minute. I'm mistaken. That wasn't a dim bulb. That was the bulb on the radio that did that. Wow. Okay. So back to what I'm doing here now. Is there audio reaching this tube? Sure doesn't seem like it. Big whopping hum there, so I don't think I got the right pin. I'm lost. I'm a lost puppy here. Come on. 35L6. 35L6. I did not plan on doing this. In fact, We're going to be driving on the road today, but our plans have changed. 35L6. Grid is 5. Grid is 5. 1, 2, 3, 4, and 5. So this would be the grid here. This is the grid. Nobody there. This can't be the grid. Something wrong here. Okay, found my wiring error. So I've got this capacitor in the wrong spot. Wait a minute. Oh yeah, that's right. I did the capacitors and I said, nah, no need to test the radio. Yeah, no, that's not true. So I've actually got a capacitor grounding the grid on the output tube instead of over here fetching the signal. Ah, stupid mistake. Okay, radio off. Radio off. Let's take this out. My mistake. Okay, so we're just going to swing this capacitor over to the right spot. And there you go. Once again, exposing my mistakes on video. Okay, let's try this once again. Now, first I have to double check the voltage on these chassis because I've unplugged it and replugged it here. So let's see first. These are off. Yep. Got that in. Okay, give it a little bit of power. Now, and we got these in the safe way. Well, it sure looks like it, but there's too much at stake here. I'm going to reverse one. Everything's at stake here. Here we go. Yep, okay, that proves it to me. Here we are. Okay, we're ready again. Is it going to work this time? Interesting, I was comparing the two radios quickly. I didn't notice the difference in those two capacitors. I looked at them, but you know, not thinking, is there something wrong here? I'm just looking at them. Shame, 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 shame. Dun, da, da, da. Ready now for the contest with the dim bulb in place. There's really no reason to have it there. It's really hard for me to get this to stand up here. Okay, full power. Give it a works. Sound from here. Okay, now we'll tune these to the same spot. Not that it really means anything, it's just a random spot here. 700. And what do we hear? Ooh, see that? I grabbed them both. Good thing I checked that stuff. I got to turn this way up compared to this one. Okay, that's kind of a. Let's go up to 1400. Again, there's nothing there. It's just going to be noise and interference. 1400. Now, these radios could interfere with each other. The local oscillators can be transmitting into each other. So we might hear heterodynes and weird stuff. Are we doing this? We should actually, I think. So the sound in my shop is stereo. So, and the microphone, just so you can see the relationship here, there's the speakers and the microphone's hanging right there. You can see the microphone hanging. So it's pretty much where my head is, kind of. I never thought about that. That microphone is just about where my ears are, so kind of hearing what I'm hearing. I don't know if you can pick up stereo. Maybe I got to put on headphones to hear the stereo. Yeah. Now, what I do in the evening when I'm listening to shortwave radio is I have two radios running. One of them is like this. It's just a string, and actually it's gears, but you can't tell exactly what frequency you're on. And the other one is a digital one. And what I do is I play, I have a stereo setup with the left and right speaker. I play one radio out of the left, one radio out of the right. Then I take the inaccurate one and tune in something because it's a wonderful radio to use. And when I get it tuned in, I don't know for sure what frequency it's on. So to find out, I tune the other radio with the digital dial. I have headphones on. I have one radio in one ear and the other radio in the other ear. And I'm telling you, you can tune this other radio rapidly. And when you cross the point where they're at the same spot, it is so apparent in the headphones. That's how I do it. I do the same sort of thing here now. It's just not headphones. It's two speakers sitting out here. I'm going to try that. So what I'm talking about doing is I'm going to turn them both up. Then I'm going to tune one and see if there isn't a point where suddenly all the noise and everything just balances out into the middle instead of sounding like two stereo channels. And why am I doing this? Just because I'm clever. I'm not clever because I'm curious. We're going to find out if I'm clever. So I hear these two speakers separately from my ears right now. This one's a little louder. Let's see if it turns into mono. So what's happening is this one's getting a lot louder as I do this. Is it something over here? So I think there's a chance that the speakers are out of sync. They're going like this, and they'll always sound. Under those conditions, they'll always sound like two speakers, even if they're producing exactly the same kind of mono sound. If your speakers are out of synchronization, out of polarity, that could be the case here. So that experiment kind of flopped. I didn't. There was no point where I could say, "Oh yeah." Now they're right on top of each other. So let's put a signal to them, and we'll check dial accuracy and signal response. The problem is I have to feed a signal in an identical way to these two radios. So I think what I'm going to try, and I'm not sure this is really going to be effective, is to use a loop here of wire. Just kind of position it in a sort of balanced way between the two radios, and we need to turn this on. Let's see how this goes. Okay, so one of the rules of using your imagination is to not be too critical of what shows up in your head. In fact, initially, when you're trying to come up with ideas, you should not consider the validity of any of them. Just keep trying to come up with another one and another one and another one. So how should we put this? So I don't want this moving once we get started here. I should actually hang it like that. Okay, get clever. Am I clever? Another chance, Jim. That's clever. So now I want this to be kind of fixed in place too. I don't want this swinging around. If I'm going to bump it or something, I don't want to bump it. And I want this to be not aimed at anyone in particular. Now it's a little loosey-goosey there. Let's see if we can... There. Okay, that's pretty good. Now, how central is that to the radios? Not quite. In fact is, it's coming in this way on this radio, but it's not coming in this way on this one. It's going in that way. Would that make any kind of difference? I doubt it, but who knows? Who knows? That looks about right, eh? Don't you think? It looks about center, equidistant, and all that kind of stuff. Don't think I can get it much better than that. Again, this really isn't scientific, so why should I worry? I think these are both tuned to 1400. It's interesting. One hears that sound. This one doesn't. That's kind of odd in itself. Okay, everybody lined up now? We'll swing in 1400 here. Okay, fairly strong 1400. Who's doing that? So this guy's playing it. Isn't that interesting? Oh, can't see the frequency. Come on, come on. Gotta be able to read that. Okay, so repeat what I just did. So I'm radiating out of this loop at these two radios. I'm just verifying what I'm doing. 1400, this is quite a strong signal going into the loop. Should be easy for a radio to pick it up. The one on the right. $13.75, and it could just be, dial adjustment, so we won't pay attention to that. Hardly hear it. So there's our first real difference. This guy can receive at the high end, and this guy cannot. Okay, that's kind of interesting. Let's go down to the low end. See, the hiss just disappeared as I turned it down there. We'll stick this on. Let's try 600. This one keeps going. Didn't fade out. 600. Wait a minute, you shouldn't be receiving anything. There goes that click. Isn't that the strangest thing? What in heaven's name is that? Let's do it this way. Here's 590. I convinced myself this control was shot earlier. Okay, volume comparison. These knobs are exactly the same angles here. Listenable at that point. Same point over here. That's pretty similar, I think. Okay, we're going to go up a little higher. No question this is weaker. Tuning issue? Nope. Just listen to the sound quality, the amount of hiss and all that kind of stuff. There's better tonal quality over here. Less noise and interference. Here comes that clicker. Here comes. What's the difference in the sound here? Now there's another thing that the stereo salesman who told me all these interesting facts. I mentioned earlier about the 7-second long sound memory and using white noise from an untuned FM receiver to listen to speakers and stuff like that. He told me another one. For the life of me, I just forgot it. It'll come to me in a sec. Oh yeah, I remember what it was. He said, the way you hear sound, inevitably, the louder it is, the better it sounds. And so this is known by salesmen. And so they'll play you this one. That sounds great, but listen to this one. And they'll play it louder. Now, they're not identical, in a stereo shop, you're not being shown identical machines, right? Different machines, different speakers, all sounds a little different. What you won't pick up is that the salesman is just playing it louder. The one he wants you to buy, he's playing louder. But that's an important thing in here to realize too, is that and if you look at the hearing response of the human ear, it's not the same at all volume levels. It varies as you go up in volume. So lots of problems with our ears. It's just doing that stereo balancing thing. Well, lower output out of this one could be because the output tube is a little weak. Perhaps some of the other tubes are a little weak, so the signal's not built up as strong through the radio. Hard to say. An alignment issue. It could even be that. It could be almost anything, couldn't it? Let's tune in a test signal at 1 million hertz and see and hear what we hear. Okay, so here's 1 million. Again, it's a fairly strong signal. Go ahead on this guy first. So millions up here. So I believe I aligned this radio, I can't remember now, but I think I aligned it at one point with the scope hooked up right to the diodes of the detector, and I know now from experience with this radio that's a no-no. It threw the tuning off. Maybe the same thing has happened over here. If that's the case, then there's only one IF screw I need to adjust to bring it back. That's right. It's this one, I think. Well, that kind of ruined the whole experiment, didn't it? Let's go back and compare now down here to the actual radio station. We'll see if that just seems a lot better, doesn't it? This one's louder. This one's louder now. So I think that's what I did. I think I booped it up by sticking my scope without thinking hard enough about it right onto one of the IF transformer coils, basically, is what I did. Okay, Well, this is fun doing this because it's helping me get things sorted out with both radios here. But now they're very similar in operation. This guy's quieter. Let me try that. Let me try that. This shouldn't help. No. Put it right back where it was. Okay. Let's go up to the high end and compare them. But there's a station here at 840, which I can almost get without a bit of help. I'm going to give these radios a bit of help. So what I'm going to do is I'm going to change this coil from sending out the signal generator signal to hooking up to a long outdoor antenna. And this is just like a re-radiator, if you like. Just bringing what's outside on my long wire, bringing it inside. And let's just see if this had any effect. Not really. Yeah, volume's down.
Defensively, their separation that way, does it make up for maybe the lack of offensive talent compared to the elite teams?
Yeah, I don't think I'm going to be able to do that. I don't think I'm going to be able to. I have another plan. I have another way of doing this. Let's try another way. Okay, this somewhat crazy looking thing here. What I'm sticking back here is basically a chassis. Whoops, let me turn it around here. Do it this way. Well, no, I better keep it this way. I want to get that coil there as close to the radios as I can. So this is just an antenna, same as these, off a radio. Some poor radio donated its antenna to me. And the chassis has the tuning capacitor on it from its days when it was really a radio. Well, I'm going to hook up this outdoor antenna to this loop, to the, I don't know if you can really call it the primary side. So this loop of wire is actually two loops. These antennas are actually two loops of wire. One goes around once or twice, and then the other wire is all the rest of it. And I've hooked up my outdoor antenna to the wire that goes around once or twice. And I'm just going to turn this up a little bit. Now if I tune the capacitor back here, that's back there, the tuning capacitor back there, and make that coil resonate, it will boost up the signal here in the shop. Is it true? Yeah. Okay, now how helpful is that? So I'm going to separate the antenna. That helpful. And the other radio. About the same. This just gives us, it's just hard in my shop to get a nice AM radio type signal down here. So with this kind of re-radiating it and boosting it too, because it's resonant, gives me a fairly strong signal in here, and hopefully balance between the two radios.
I think it's a real testament to the way Nickers use the game. That he's not as worried about failure as...
It's an interesting psychological effect here. These two radios playing, I am sure the sound is coming from way up there somewhere. Having that weird phasing thing going on in my ears, I guess, and it just gives me the impression the sound is coming from over yonder. more treble coming out of here, I think. You hear that heterodyne? It's not really a heterodyne. Well, I guess it is. Yeah, you could say that tone. There's no tone over here.
The thing I always wonder is, do you think there's a bit of a tipping point for the Raptors in terms of they play such great defense because of the sum of their parts and because of their coaching, but that the one flaw is, I think over the streak...
The clicking is barely audible on this radio. Gone from here. Still hear it here. Gone. What a tricky thing. Oh. Ah, there it is. Sounds the same. Oh, that's right. I disconnected the other guy here. Let me get him back up here. Where'd the clip go? Let me go. Okay, don't see it. Okay, what do we got happening now? So we got a signal at 1 megahertz coming out of this coil. You can hear it on this radio. Tune it in. Pretty much bang on 1 million hertz. A lot of hiss. Pointer's not correct. Where's the hiss? There's some hiss there. A lot more over here. A lot more. Weak signal. Could be the antenna arrangement. So I'm going to move this around a little bit. Not doing much. A little closer gets a little stronger, of course. But not a lot of change there. That's kind of interesting too. That's very strong when you do it like that. It's about the same, in effect. Could null it right out. That's interesting. It's just a null point right here. So I think it's just, this radio is just sensing the antenna kind of moving around. This one's doing something a little different. This one seems to grab onto it. That's my imagination. Just shows you if you're working in your shop and you happen to have things arranged just inappropriately, you get this. Get that. When you could get that. It's almost as if I can see an invisible line traveling up like this out of the back of the radio, and I'm dipping this across the line and it's making that sound. The other one? Not quite the same. I was listening to this radio. Wait a minute. Yeah, no, it's okay. Everything's okay, man. I forgot what I was just doing. So what I was doing was I was holding it still and tuning through the signal and listening to just little things. I want to get this in a fairly weak spot here. Who's winning? Which champ is winning here? I don't know. I've confused myself at this point. Yeah, they're picking up the same noises. Just grabbed onto both at the same time. Okay, I survived. Can't possibly. I'm going to try to tune the two of them down at the same time. I can't possibly do that. Okay, let's go for 840 here. Tune this up. There it is. So my outdoor antenna is now radiating off of this resonant loop quite strongly, and that's why the signal's so nice over here. Now there's that effect. If you're listening in stereo with headphones, you'll probably hear this.
Oui, Michel, on rappelle, au Nouveau-Brunswick, le gouvernement est dans un contexte minoritaire. Je vous donne les chiffres parce que, à ce moment-ci, c'est particulier. conservateur. Après le départ devant le 20, progressistes conservateurs ont 20 sièges. Les aussi. Donc, 3, c'est le Parti vert, des Brunswick, un candidat indépendant. J'étais indépendant.
The pointers are not in the same position, just slightly different.
Dans quel scénario on joue présentement?
Sound is pretty similar, wouldn't you say?
C'est difficile de dire avec certitude la suite pour l'instant. Mais là, c'est la première fois depuis
Volume, now, volume, let's see.
francophone ministre au sein d'un caucus. C'est du jamais.
This guy's louder now. He's winning.
C'est la grande question. C'est la question.
Okay, we'll try some kind of sensitivity thing here. We'll tune up to a spot. Problem is I can't tell noise, interference type noise from just atmospheric noise. I think this is a spot. See if I can find it on the other radio. How will I know? That noise I hear in 2 speakers. This noise is just coming from everywhere. So I think they're tuned the same. Well, we'll find out easy enough. I'll leave one turned up. It's right around 1400. Signal generator. Hey, how come you're not showing up? This is hooked up here. 1400. There it is. So what I'm doing is I'm listening to the noise in the background, just comparing it between the 2 radios. It sounds kind of the same. Oops, wrong thing. I'm just trying to find a quieter spot to do this. Okay, now, so what I'm attempting to do here is compare the sensitivity of the 2 radios by turning down the output of the signal generator until you can barely hear it on one radio, and then we'll compare it to the other radio. So, now, hopefully I'm not influencing things too much by reaching around. Doesn't seem like it. And this is tuned right on the money. Okay, let's go down by a factor of 10. You can barely hear it. Okay, up by a factor of 10, down on there, up on here. Make sure it's tuned right in. Okay, and power down by 10. It's harder to hear over here. That didn't help. It's more distinct here. The risk of messing everything up So it could just be that the antenna is not transmitting a similar way to the two radios. I can hear it in there, but it's just much clearer over here. And then, just to be fair, I'll mess this one up too. This is the antenna trimmer. Get me to adjust. Interesting idea now. You barely hear it here. You certainly know it's here. That's kind of how this is. This is right on the fringe. I'm going to swap detector tubes in these radios. So the detector tube is going to be hot. Is it hot? It's going to be hot. How hot is it? Hot enough to hurt me? Not really, really hot. But right beside it is a hot one. Come on out. Okay, that's out. There shouldn't be any. Oh, this feels a lot hotter. This feels a lot hotter. Oh, that's kind of interesting too, isn't it? Ah. Maybe because my fingers were already preheated. Maybe that's what that was. Okay, now we're gonna have some real fun here. Okay, gents. Who wins now? Just let them warm up. Double check the tuning. Over here. No difference. That made no difference. We are now going to switch the mixer tube on these. Let's see if I burn my fingers on that. No. This tube feels hotter. Again, it's probably just because I've charged my fingers up. Preheated fingers. I get that right in there. Wow. Okay, switch on. The radios are coming to life really quick because the cathodes haven't cooled off in the meantime while I'm fooling around with the tubes. There we go. Can you hear it here? About the same over here. Maybe a little bit better. But still, the tone is right on the fringe of what I can hear on this side. And it's still quite distinct on this radio. Okay, you know what? There's more tubes to swap. The next tube we're going to swap now is the IF amplifier tube. That is some of the most fun I've had with a radio in a long time here. Will this be... Ooh, that didn't sound very good, did it? Is this radio? Tune it a little bit. Okay, so I have no trouble hearing the tone here. And over here. It's there, but it's harder to hear. One of the differences between these two radios is there's still 3 wax and paper capacitors left in this one, and they're all in the radio front end. They look great, but I haven't changed them. Could that be making this little difference? Or is it just something about the test setup? But let me just try and verify that again, the test setup thing. What I'll do is I'll favor this radio with the antenna location. Let's see. I think I'm favoring this radio. Ooh, maybe it was just the antenna. As I'm flipping it all around, it's quite critical. Yeah, you know what? This guy sounds better now. So I think my test is bogus here. It has problems. That being the case, both these radios behave almost identically at this point. I'm really not finding anything too dramatic. Well, since I fool around with the tuning a little bit of the radio, let's go back and we'll check 590. Trying to get the volume to the same level because I know that psychological effect of the volume change didn't work. So in this signal I hear a little heterodyne tones and stuff, a little bit. And this one, I hear a strong hiss. I'm sure there's a hiss here. Yeah, for sure. What's that all about? Okay, let's see if we can swap some tubes and make that hiss travel. The hiss effect, which I don't know what it is. We're going to start with the front end tube here. Just see what happens. Oh, I've had my phone in my pocket the whole time. So I hope you haven't been listening to my phone blipping and chirping. Okay, where is the hiss? Who's got the hiss? Still this guy. Very distinct. Okay. Switch it off again. We're just we'll do the I think it's a 12BA6, isn't it? 12SK7. 12SK7. I'm just thinking of another radio. Too many radios in my life. Did the hiss travel? Hiss is still here. Okay, one more tube to change. Yeah, I'm not bothering with the output tube because I just don't see how it could generate a hiss. That probably means it's responsible for it. Come on out. In you go. In you go. I mean, this could be the speaker response. The speaker response may be better here at higher frequencies. Hearing the hiss, you can't hear it over here. I doubt that. There's no hiss here compared to this radio. Okay, tuning. Is it tuning? Did I get them off tune? It's right on. Clearly a difference. I've swapped all the tubes that I thought could cause it. So we'll swap the output tube and see what happens here. Right? I'm not grabbing that tube with my hand, that's for sure. Somewhere I need a cloth. What do I do with it? Here. This one here. Looking for it. Does it say tube on here? It doesn't say tube. Okay, out comes this one here. I don't know why I think it can't be an output tube. Put that there. And this one. Let's just double check these. 35Z5. Made by Marconi. This is a 35L6 and 35Z5. Oh my gosh. 35L6. 35L6. Swapping. Tongue saw. Tongue saw. Where did they ever get a name like that? Imagine proposing that name to your board of directors. The new company should be called Tongue Saw. Pardon me? Tongue Saw. Tubes are in. Power's on. What's that? So this tube has come with more volume. There's more volume over here now. This one's quieted down. This is how they compare. This one's full of hiss. Well, the only thing I can think of now is that it's bad alignment is what's causing the hiss. Or because this guy has the old capacitors in it. I've already diddled with the alignment though, and it didn't do anything. Or is the alignment, you know what, because I aligned this with my scope on it, just turning that one thing's probably not enough. So it's an interesting difference. It's not that it's hearing a hiss, it's that the signal, I believe, the signal coming out of the IF is lower in this radio, and that's why there's a hiss, a lower AVC voltage. or just what I said. Just what I said. Well, I'm going to stop for a while and ponder all this and come up with some more interesting things to compare in these radios and see where it gets us. And maybe it's just a matter of doing another alignment, doing a combo alignment. Combo alignment. Hey, now that's interesting. I think I could come up with something to do that. Combo alignment. Okay, so I think I'm all ready to go here. I've got the sweep generator sweeping through the IF. I've got a capacitor hanging out of here on the grid, on the oscillator grid of the mixer tube. Got the same thing hanging out of this radio. I have the scope ground connected here. The same point is marked with a clip over here so I can transfer the scope over. And I want to attach the signal generator now. So I'm going to attach the ground. This radio's on. This one is not at the moment. I have to just get one of them working right before I... so I'm attaching the ground. And attach the signal. That's good. That's what we want to hear. No, it's not what we want to see. See more than that. Why are we not seeing it? Because I've got this on ground, for crying out loud. It's right there. So you can see the ABC voltage operating. That's kind of interesting too. Compare. Hey, that's really interesting. Compare ABC voltages between these radios with the same signal in it. That's a really good test. We'll do that soon. But I'm going to flip this over to AC. So the DC component is removed. What am I going to do with that? Good question. That's pretty horrible looking. Let me turn the other radio on and get it warmed up. The light didn't come on here. What happened? Did I not turn it on? Oh my, what's going on here? Turn this down for now. This guy's not showing up at all. What happened? What has happened? Oh my gosh. There they are. Both plugged in there. Really, are the tubes not coming on? They really are not coming on. Think, what could I have done? Think, man. What have you done? Yeah, I don't know what I've done. I've done something here. Okay. Let me put the camera like this so you can watch the flashing light. I'm just guessing the plug is crummy and it's just not in this crummy outlet right. It's this big one here. Come on. Really? Okay, switch this one off. I'm going to pull the plugs out. Pull the plug out. What in heaven's name? Plug it straight in. I pulled the tube out and didn't put it back in. I had the tube laying around on my bench here. All the tubes are in there. Come on. Jeepers creepers, what have I done? What's happened? Ha! I like that. The rectifier tube was knocked ever so slightly out. Oh, you just missed the big throw of the light coming on. The rectifier tube, when I tip it up on its side, you know, sometimes the tubes get pushed on, but boy, that was hardly out of the circuit. Hardly out. Hardly out. Now I gotta... Oh yeah, so great for you. Yikes. What was that? I don't like that. I don't like that. Don't like that. Oh man, that was all nicely set up. Qu'est-ce que c'est? Something I don't like the sound of. Okay, now this goes on with the radio on. I have to put this on the input grid. Oh, this is tough to do. Yeah. Boy, if that happens while I'm doing this, I'm going to jump a mile. There. And then the ground marker. Because I know once I get testing, I'll get a little crazy about that. There we are. Once again, these things are plugged into an isolation transformer, but once one power ground is applied to it, like this black wire here, then yes, I can get a nice lift off it. The isolation is gone. So, okay. So if you're doing stuff like this in your shop, take the steps you need to take to keep yourself safe. Don't just try to imitate what I'm doing here. That would not be a good idea. Okay. Where are we at now? So we have the input going into this radio, which I switched off. Switch it back on. Start the whole thing over. My God. Patience. I'm being too patient. We should hear this, shouldn't we? Oh, it didn't come on. Oh, because I unplugged it. Okay. Oh, whoa. Okay, right back to the checking to make sure these... Oh, for crying out loud. Too much, man. It's too much. It's just too much. Okay, plug this in. Now, be careful. As far as I know, there's 120 volts between those chassis. I have to check that. I need to check it with this. Here, guy. Sooner or later, we'll get around to actually doing some radio testing. Just takes so long. Okay, watching the meter. Is there an AC voltage between these two chassis? Yeah, I'm all set to go sky high here. So we're going to reverse one of the plugs. I'm going to double check because this is a serious danger. Serious danger is gone. What if we look between B minuses? I don't know what you'd expect to find between B minuses. Let's find out. So So I'm on the AC scale here. It's kind of a weird test. I'm reading between two items. So I'm not sure what to make of it. Nothing there anyway. Not sure what to make of that. That was kind of a weird. That's like testing, having two batteries on your bench and reading the voltage between the positive end of each battery while the negatives aren't connected to anything. It's a little bit of a bogus test, I think. Okay, so we're all set now, I believe. I see on the scope a slight response. It's really not what I want this to look like at all. Let's look at the other radio. So I have to transfer both the son of a gun. I wish I could have them both hooked up simultaneously. I probably could, but I'm not going to try that. Makes me a little scared. Okay, onto the ground point. Should tune this radio the same place as the other. Okay, scope out. Whoa, don't do that. Scope in. Now I can't remember what the other one looked like. It looked like that, didn't it? Both look the same. And hoping for a much sharper dip here that I can fool around with. How can I possibly make that better? That's funny. I'm flipping the AC and DC switch on the scope and you can hear an effect in the radio. Scope is set to times 10. Did I just move it? I think I did, didn't I? Yeah. So I don't hear the variation in the radio when I do that. I'm going to leave it like that. Hey, what am I going to do? Why am I not getting a nice looking curve there? Scope is hooked up direct. The signal's going in through a capacitor. I don't get it. So see the slope coming up here, and then it's going up here. It's just not the kind of curve that I want to fool around with here. On my sweep, it's definitely going from 409. Let's make it a little bit lower. 405 is what I really want it. 405 up to 505, right on. Yikes. So I'm right at the detector past the diode output, just past the first resistor. Let's go to the top of the volume control. It's another very common place to just grab the signal. Top of the volume control. Well, you know what? It's on the other side of this resistor, and this is the one that threw the radio off, didn't it? Yeah, you can hear the... So my initial interpretation of that variation was just a loss of volume. But now I realize in retrospect the radio tuning was going in and out. So I've looked at the top of the volume control, and it's the same sort of thing. Oh no, it isn't. Okay, let's let it interfere with the radio. Go there. Where'd you go? I'm gonna bump the brightness. Yeah, it's a little more like what I'm after. That's great. Okay, now we're in business. So I just switched from one side of the resistor to another. Let me just turn the brightness down a little bit. You can see the retrace flying through the back there and coming across, shooting back. So that curve is not 100% balanced. It's got a funny little kink in it right there. It's not dead on, let me get this in the center, it's not dead on 455, or my settings could be wrong. It's just in the center of this gradual here. I'm going to switch to the other radio now. We'll compare it. So we have to kind of memorize that image. Looks like it's over this way a little bit too far. Funny kink up here. 1, 2, 3 wide. Okay, switching now to the other radio. Here we go. Just do this in the proper order. You're off. You're off. Makes the radio hiss. This one has a signal going through it, so that's why we didn't hear the hiss. Take this off. Take that off. Uh-oh. A little difficult. I didn't really plan. Trying to watch everything under the sun here while I do this. That's good like that. Flip the clip lead through the radio. Oh, don't go anywhere. You see the same little kink here. Now we're lined up more in the middle. Somehow I think they should go down a little further. It's 1, 2. It's roughly three wide at the top. So it's similar in many respects. Well, let's fool around with the IF now. Hard for me to get this on camera. So I don't have this on the turntable anymore. I can't rotate it easily. And I'm going to stick my head right in front of the camera if I do it this way. The idea is, my idea is for you to see my hand turning, and that's how you know what I'm doing. Starting on the second IF, the final, oh, this isn't even a screwdriver. Somewhere in here I've got a screwdriver. Here's one. Okay. I can't see the screw, so I have to feel out the... Oh my gosh. There it is. Oh. Okay, got it. Okay, watching the shape now. Like that. Put it like that. I'm going to try to put it right. See, I can't be absolutely sure 455 is right in the middle there, so I'm just going to go for the shape. Shape looks good now, actually. I was thinking about why some of these adjustments seem to adjust the bottom of the curve and others seem to adjust the top. And I think it has to do with the bandwidth of the particular coil that I'm tuning. It has a very wide bandwidth. It'll tend to look like it's tuning the bottom of that curve, like this one. But if it has a very narrow bandwidth, it'll look like it's tuning the top of the curve. That's my theory on that. Well, I just don't think I can make the shape any better than that. I believe the width here is really mostly determined by the physical facts of the radio. The way the coils have been done, the amount the coils interact with each other and the like. What are we doing? We're going to do the same to the other one now and get it into exactly the same position. Okay, let's just think about this. This comes off. That goes down. Pick that up. It's off. I disconnected the scope and ground from this radio, and this one got louder. It kind of nullifies absolutely everything I'm doing. Okay, here we go again. Signal ground. Signal. Scope ground. Scope. Same spot. Here we are. Now it's a little over to the left, and a little kinky up here. So see if I can get it just like the other one. There we go. So I want it over there. Everybody over there. Oh my gosh, this is the one with the voltage on the on it. Hey, is that the same as the other radio? Ooh, that's something worth testing. Everybody over. Yeah, that's strange. Everybody over. Okay, one guy's holding out. I think it's the last screw here. No. So I can't seem to get a nice shape happening right in here. A nice shape happens a little over to the... Well, it's pretty close now. Keep going. Keep going. Watch out. Don't short it. Should be using a non-metallic screwdriver. Whoop. Yeah, I just shorted it there. No idea what it is I'm actually shorting. Oh, there I did it again. Quite a spark. Oh my gosh, I gotta stop using that. Whoa, careful, man. That's a little too fat. Son of a gun. Try this one. Make sure I do it on the radio that's running. Okay. Well, that seemed to narrow it up, contrary to what I was saying. So I'm just fiddling around here, kind of just playing around. Well, that looks really nice. Much steeper sides. It's just about dead center in the middle, too. So this screw, I'm back in the high voltage can with it. That's me shorting it out. It doesn't spark on this side. This screw doesn't spark. Come on. Holy smokes. Okay. That's 2 divisions wide now, so I've narrowed it. I've definitely narrowed it. Be interesting to compare the sound. I'm going to go start over. No, I'm not. I'm going to start the next one. And then the last one. Can get any better than that. That's 2 wide. Okay, let's go back and compare it to the other one. Two wide and 2 down. 2 wide and 2 down. Okay, so this one is 1.5 down and 2, almost 3 wide. Let's see if I can fiddle this one into a smaller shape. I don't think that one's going to help us much. That's pretty strange. So I think it's out here, and as I bring it in, you start seeing it. But as it matches up, this no longer is as deep. I'm wrong about that. Right there. Look, we're about 2 wide and not quite too deep yet. Seem to tighten it up with that one. But you know, it's oh, I didn't get this in right. So that's about identical now to the other one. 2 wide and two down. I think the other one went right down to here. Let's hear what these sound like now. Okay, think before you act. Okay, without tipping them or doing anything, just leave them like this. There's no signals. Now there's no signals in here to interfere in any way. What do we got? Right, come on over this way. scope won't mean anything. Similar volume. Okay, we're going to find a station. It's really good. A lower tone on this radio. To turn the volume up much higher, a little more hiss with it. Yeah, quickly, this is much louder. Just on a long shot, and shame on me for doing this, I'm going to twiddle the antenna adjustment here. Yeah, just a wee bit louder. Straight up. Much lower volume here. Okay, you know, there's still the rest of the whole alignment procedure to go through, the two radios together on the front end. I think it's worth doing. Okay. You know, at least for educational purposes, but I think I'm getting a little better result out of this. I think this one's winning now. Oh, touch them both. Good. Well, for me, lunchtime has come. Lots of fun here, but I gotta stop. Eat some lunch. Have more fun later. Okay, now one of these radios has a voltage on the screws, on the trimmer screws for one of the transformers. I want to see if the other radio has the same voltage. That's very odd. I think it's really because something is wrong. So let me start with the radio with the voltage. And I have the feeling it's different from one screw to the other, which makes it even weirder yet. So I'm on DC here, and we'll read it. You should read it to the B minus. Hold that there and don't move. Now I can't see the meter. Yes, I can. Here's one screw. That's right, it was minus. I thought it was minus a few volts, and the other screw. B plus. I don't think that's normal. Okay, we'll try this radio. B minus. And now the screw. Where's the voltmeter? Nothing on that screw. This one had a minus on it, and this one Yeah, there's no voltage there. So there's definitely something has happened inside this radio to cause the screw to become electrified, and exactly what that is, I don't know. I'm not going to investigate any further. I'm not going to take it apart and try and figure that out. But never seen that before. Now, occasionally, some of these cans are insulated. Not in this radio. Both the IF cans are grounded to the chassis. Okay, that's interesting, but not going to help much. Now what? So I thought this one had more hiss than this. The signal to noise ratio wasn't as good here. They seem to be the same now. Still feels terrible. So what we're going to do now is this is a replacement, or this is a replacement. One of these two have been replaced, I think. My guess is this is the replacement. It also seems to me I've done some, not baby champs, but some champs, and they kept requiring a volume control to go into them. Curious. Very curious. Okay, alignment. Continuing with alignment. So, I think how can we do this? So we follow the book. We use a single frequency at, I can't remember, 1400, 1500, somewhere up there. And we do everything up there pretty well, except one thing. Let's do it. Let's do it. And I'm just going to check the instructions here quickly. I won't put them on the screen. I just want to be sure. 1400. So we're going to do it with an induction technique here. Use my overly complicated looking thing here. I had a dial I was going to try on this, but it won't fit by any means. That's the remnants of the old dial. But I'm going to find a dial and get it on there at some point. 1400 is up this way. Tune this to 1400. We'll just go right there. 100. Okay, I think that's good enough. The first thing is the oscillator, which I've done so many times. Hey, what happened here? Go this way. you hear that? It's coming out of this radio. That's a local oscillator in this radio passing 1450. 1500. Now, I'm not going to do the oscillator because I've done it and it's set good. I'm going to tune the radio for I need the meter. Meter. That means I'm going to have to transfer this from speaker to speaker if I want to use the same meter all the time. I think I do. There we go. That's good. I got everything. Not the whole shooting match, but up on. Why is all that noise going away? Just because I hook up a meter. Why would that happen? Put it on the list. How about this? Put that on the list too. Okay. Now we want to max that meter. First by tuning the radio. Oh jeepers, every time I touch it. Tune the radio so it's tuned in right on the money. Okay, that's it. Again, the reason the meter bops up and then comes back is the AVC voltage doing that. Now, the adjustment is only one thing up here. That's this. That's the only thing. It's right there. I have the feeling the same thing's going to happen on this side. Is there something I'm missing here? There's something I'm missing out on. Rocking. Rocking it. It's the rocking part. Okay, let's try the rocking part. This. So I'm looking at the meter, and in this current arrangement of these two adjustments, we get on the, I'm going to read on the lower scale here, this scale, 2.1. Can we get any higher than 2.1? Okay, so I'm going to try a different position here on the tuning slightly. AVC makes it very tricky. I can't see how I can rock this up any higher. I don't get any good feeling out of this. Okay, we'll just switch over to the other radio now and find out what happens. So first, off the speaker. Gain. Down on the volume, up on the volume. Oh, this sounds totally different. It's a noise signal right there. How come it wasn't there on the other radio? Seems like I get a much higher reading on the meter, a lower volume. Add it to the list. Okay, tune in maximum. This doesn't get any better than that. Trimmer. Right on the money. Everything's fine. I'm not getting anywhere. There's nothing more to do to it. Yes, there is. Yes, there is. There is a reason for doing the oscillator here. The difficulty in this radio is you don't know for sure where this pointer is. So I've been going for these squares here. This is my reasoning. I'm shooting for the center of the front line there, right there. So I would turn this like this. But if I chose the center of the box, then I would tune it like that. And if I chose right over here, I'd be way over here. So where do you go? I don't know. The thing is, you get this a little bit wrong, and then the front end and the oscillator don't track. You lose a lot of performance very easily. So you know what we're going to do? I just realized what I can do. Does it make sense to do it? Let's get the SDR going and look at the local oscillator frequency. And how's that going to help me here? Because it comes back to, and the pointer itself, these two pointers are not necessarily on the shaft at exactly the same position. You know, I'm probably just killing myself here over nothing. Well, we know 14. Let's compare. Let's compare 14 on the two radios. Where's 14 on the two radios? So this one first. I'll get this on 14. I would say 14 is pointing at the corner of the box. This one's a little further up. If we tune right through here, let me turn this up a little bit. Gets a little quieter up here. It's working really quite well. There's no help here on the radio, it's just the radio and its antenna. This guy too. I hear the heterodyne here. What I assume is a heterodyne. It's a little different over here. Through that station, I don't hear much interference. Heterodyne or... Go through this one. Maybe because of the slightly different angle of the radios. The antennas aim slightly different. I can't imagine a couple of degrees would make any kind of difference in that respect. Hear that sound. See, between this station and the next one, what do we hear? One small noise. One small noise. There it goes. $640. Much worse reception here. I could do this all day, by the way. Video could be 16 hours long. So I tighten this way down, it boosts it. I'm doing the antenna. But this is where it normally is sitting here. Based on the other end of the dial, let's try this one. French. Where'd it go? Much louder here. Change the volume control. Maybe the resistance isn't correct. As for sound quality, really very similar. I don't think I can tease out any differences between these radios anymore. Let's check them for temperature. So both of these radios have been on now for hours, continuously on for hours. So the way this is set right now, 35 degrees will show up as red. Let's change that to 65 degrees. Anything 65 or close to 65 or over will show up as red. Really tricky getting this to come up on the camera you're looking at. Really, really tricky. Maybe like that. So I can see something hot. So if you look at that, I know this is difficult in the camera. Can you see that it's kind of wavy over here? It looks kind of wavy. This thing can see hot air, as I have discovered. Hot air and cold air if you have it set right. And of course the air is moving. It's, in this case it's convection going up. So, okay, so the hot guy down here. Two hot guys. Can you see them there? You cannot. You cannot. You still cannot. Son of a gun. It's so hard. Let me try this. This is what happens when you do these things live. Okay, now you can kind of see it there. Kind of see it. So I see two hot items there. 1, 2. The highest temperature in there is 95. So that one, this one here is about 72, and the other one, this is trickier. You're not going to be able to see it, I don't think, when I do this. Son of a gun, this is hard to do. There we are. 75. So the two high wattage resistors down are about the same temperature. Now we'll come and look at this one. Kind of the same sort of display here. In this case, the highest temperature is 105. This one look different. What is it? It's 105. The resistor in this radio is 105. The resistor in this radio is, let me do it properly now. Oh, same thing, 106. Same temperature. That's hot. That's really quite hot. No wonder the original resistors just couldn't take it. These ones can. This is not too hot for those resistors. I laid them in up against the side of the radio to try to get the heat to dissipate from them too. Okay. So this resistor is the same temperature, 70 and 70. And if there's anything else in here, those are tube sockets that are starting to come through, and that's... What else can I do? I don't know. I'm going to stop now and think about what else I can do. Okay, I think the last thing I can do is see these guys work in their cabinets. Here we go. Oh, put the power on. Here we go. Oh, there's that funny light effect again. You're not supposed to hear this kind of music here. Oh, I hope I don't get a copyright hit for this. I'm sure to. Yeah, I can't do this. Okay, here's what we're going to do. Listen a bit. Listen for the bass over here. Oh, okay, it's back to a voice. Back to a voice.
Cette musique de Magic System tirée de leur album Africainement Vôtre. Un artiste de la Côte d'Ivoire suggéré par notre entrepreneur de la semaine, José Couadio. Et maintenant, c'est Diane. On parle culture, évidemment, comme à chaque jour. Et quels sont vos deux sujets aujourd'hui?
C'est une journée spéciale, le 14 février. Donc, j'ai trouvé un superbe film qui commence aujourd'hui à Toronto qui s'appelle, le film français d'ailleurs, Portrait de la...
It's better sounded here.
And this is what happens, and as a consequence, some people have actually drained bank accounts, lost their homes, taken out lines of credit, or drained their line of credit. The answers is a single partner of Google, Facebook, Microsoft, and more, and with nearly 2 decades of experience help. This update is brought to you by your Toronto area Ford dealers. DJCL Toronto. Radio. Sportsnet 590.
Heterodyne's much stronger in this radio. It's just a loop attached to my outdoor antenna, right? Doesn't make much difference there. Good luck, Maple Leafs. There's more bass out of this. Yeah, a little less treble and more bass out of this. That's about it. I think that's about it for these two guys. I can't wring any more out of them. You know, they're pretty identical, really, in their operation, and both working really good. Happy with that. Okay, so wow. Okay, so this is the longest video I've ever shot, and thank you so much if you managed to watch the whole thing. I hope you found it fun and interesting, and not sure exactly what all it amounts to, but there we are. I need to get more radios. See you.